Today we're going to start talking about radical and surds. Now throughout this entire unit, I want you to focus on our essential questions. For this chapter, our essential question is, how are radicals and indices similar? And how can we apply the rules of regular numbers to radicals? In which cases can we not apply these rules? Radicals are numbers that are written using the radical sign. So recall that this could be the square root, the cube root sign, or any other root power that we wanted to do. For example, we could do the 10th root. Whereas surds are radicals that are irrational. For example, we take the square root of 2, that gives us a irrational answer because that's a decimal that never terminates and never repeats. So it's an example of an irrational number. Other examples of irrational number are numbers such as the square root of 7, square root of 3. Example 1, determine whether each of the following is a rational radical or a surd. Let's look at square root of 36, which simplifies down to 6 since it's a perfect square. 6 is a rational number, can be written as 6 over 1 or as a fraction, so therefore this is an example of a rational radical. Now let's look at example B, the square root of 72. That is not a perfect square, so I have leftover things and we have decimals, which makes this an example of a surd. For part C, neither the square root of 3 nor the square root of 14 are perfect square roots, so that means that C is a surd. On D, 25, square root of 25 is 5, square root of 49 is 7, so both of those are perfect square roots. That makes this a rational radical. In E, the square root of 16 is 4, which makes this also a rational radical. Our official definition of the square root of A. Square root of A, written as the square root symbol with an A underneath it, is the positive solution of the equation x squared over A. So the key to that is this A is always positive when you're underneath the square root. Positive solution. The square root of A is a positive number, which obeys the rule square root of A times square root of A equals A. A cube root, on the other hand, written the cube root of A, satisfies the rule that the cube root of A, quantity cubed, is equal to A. This could either be positive or negative. If A is positive, then the cube root of A is also greater than 0 or positive. Whereas if the A is less than 0, then the cube root of A is also less than 0 or negative. Okay, let's start section A, which is the basic operation of radicals. The objective for this section is to use basic operations to simplify radical expressions. The best way to teach how to simplify is through examples. So let's look at example number 1. In this, we're asked to simplify the square root of 3 quantity squared, which is equal to the square root of 3 times the square root of 3. And by our definition of square root that we just went over, that should equal the number 3. Now looking at example B, which is the square root of 3 raised to the 5th power. So let's expand this out. Square root of 3 raised to the 5th power should be the square root of 3 times by the square root of 3 by the square root of 3 times square root of 3 times by the square root of 3. Now let's do these in pairs. The first two, using our definition, should equal 3. Next two, by definition, should equal 3. And then we have this square root of 3 left over. Combining like terms, 3 times 3 is 9, so our final answer is 9, the square root of 3. Let's look at example C. We have the cube root of negative 7 quantity cubed. And by our definition of square roots, this should equal negative 7. Okay, looking at example D, we have 1 divided by the cube root of 11 quantity cubed. So we're going to use our distributive property that we learned earlier in the year. That becomes 1 cubed divided by the cube root of 11, quantity cubed. 1 cubed is simply 1, and then using our rule of cube roots, we know that bottom is equal to 11. So our answer is 1 divided by 11. Okay, let's do example E. I'm going to do it over to the side over here. Let's see what 10 divided by the square root of 5 quantity squared would simplify. So using our distributive property, we get 10 squared divided by the square root of 5 squared. Well, 10 squared we know is 100, and the square root of 5 squared is equal to 5. So 100 divided by 5 is simply 20. Okay, let's look at example 2. Our directions are still to simplify. In part A, we're going to have 3 the square root of 5 quantity squared. So again, we're going to use the distributive property and distribute that square to each base. So we have 3 squared times the square root of 5 quantity squared. 3 squared is equal to 9, and the square root of 5 and square inverse operations cancel each other out, so we get 5. So that final answer is 45. In B, we have 2 the square root of 10 quantity squared. So again, we're going to start by doing the distributive property, and we end up with 2 squared times the square root of 10 quantity squared. Well, 2 squared is 4, and the square and the square root cancel each other out, so that's equal to 10. 4 times 10 is 40. Example number 3. Directions are still just simplify the expression. But we're going to get a little bit more complex on this one. We have 3 the square root of 2 times by 4 the square root of 2. So we're going to combine like terms. So the numbers outside the radical we multiply together, and then the numbers inside the radicals we multiply together underneath the radical. So that gives us 3 times 4 times the square root of 2 times the square root of 2. 3 times 4 is 12, and then square root of 2 times square root of 2 is square root of 4. And we know square root of 4 is just simply equal to 2. So our final answer is 24. Let's try another one like this. For example B, we have 2 the square root of 5 times 3 the square root of 5. Putting our like terms together, the whole numbers are 2 times 3, and then we have times the square root of 5 times the square root of 5, which is equal to 6 times, well, square root of 5 times square root of 5 is square root of 25, and the square root of 25 is simply 5, so our final answer is 30. The last thing we're going to look at in this video is we're going to look about adding and subtracting radicals. And we can add or subtract like radicals. Now I want you to recall from when you learned algebra that if we had something like 3x plus 2x, our answer would be 5x. We just add the 3 plus the 2 and keep the same term, the like term of the x. Well, we're going to do the exact same thing with radicals. So let's say if I have 3 the square root of 2 plus 2 the square root of 2, that's going to be equal to 5 the square root of 2. Noticing that I just keep the like term of the square root of 2. All right, looking at our very first example here. So our instructions are to simplify these radicals. So let's look at A, which we got 11 the square root of 3 minus 8 the square root of 3. So combining the like terms, we're going to take 11 minus 8, which gives us 3. And then we're just going to keep the radical. So we're going to write it as 3 the square root of 3. All right, looking at example B, we have negative the square root of 10 plus 2 the square root of 10. So we have negative 1 plus 2, which is simply 1. And then we keep our common radical. So that's going to be 1 times the square root of 10. And simplifying that, we don't write the 1, so we're just going to write it as the square root of 10. Now we can do multiple terms. We can add and subtract as many terms as we want. So in C, we're going to take 9, the square root of 15, minus 4, the square root of 15, minus 11, the square root of 15. So notice all of these are square root of 15, so they're all like terms. So I'm just going to simply take 9 minus 4, which is 5, minus 11, which will be a negative 6, and then copy down our like radical, which is the square root of 15, for our final answer of negative 6 times the square root of 15. In D, we're going to look at what to do if we have multiple terms, like if we have x's and y's. Notice we keep them separate. So the same thing if we have a square root of 2 and the square root of 3, we keep them separate. So for D, we have 5, the square root of 2, minus the square root of 3, plus the square root of 2, minus the square root of 3. So we're going to keep our like terms together. So notice we have two terms that are square roots of 2. So let's combine those two terms together first. We got 5, the square root of 2, plus the square root of 2. Now let's put our square root of 3's by each other. So negative square root of 3 minus the square root of 3. So let's start by adding our like terms. So the square roots of 2's add together equals 6 the square root of 2's, and the square root of 3's subtract equal negative 2 the square root of 3. Okay, we have one more example. I'm going to try to fit it in here at the very bottom. Let's see if it'll fit. So E is going to be negative 8 minus the square root of 15 plus 7 the square root of 15 minus 13 minus 6 the square root of 14 plus 3 the square root of 14. So now first thing I need to do is write my like terms by each other. So I have a negative 8 and I have a minus 13. Oh look, I forgot my minus sign here. Let's fix this. Okay, let's try this one more time. Let's combine our like terms and write them by each other. So we have a negative 8 minus a 13. And now let's look at the radicals. So we're going to combine the square roots of 15's together and then the square roots of 14's. So I have a negative the square root of 15 plus 7 the square root of 15. And then for our 14's, we have a minus 6 the square root of 14 plus 3 the square root of 14. And now we'll just add the like terms or subtract the like terms. So I got negative 8 minus 13, so that's going to be a negative 21. Then I have a negative square root of 15 plus 7 the square root of 15, so that's positive 6 the square root of 15. And with the square roots of 14's, I would end up with a negative 3 the square root of 14. So I know it's hard to see here, so I'll reread this. The final answer for example 4, section E, is negative 21 plus 6 the square root of 15 minus 3 the square root of 14.